All right, so we have our messenger RNA, we have our rRNA, and we have our tRNA. So another important thing are the binding sites. Once we get through the process, and I'll talk more about what happens in each binding site, but this is called the A site, this is called the P site, and this is called the E site. So basically what happens is that the tRNA are going to work their way through these different spots. And I'm going to get us to stand up and kind of act this out in just a minute. We'll talk through the picture and then we'll do that. So this picture at the bottom is where the mRNA is working its way through, and this is where the tRNA comes into play. So this part is RNA, and then what does it say this thing is at the top? An amino acid, which are the building blocks of proteins. And then this 3 nucleotides at the bottom here are called anticodons. Yep. Okay. Yeah, they do. Good. And then the mRNA, once it gets to translation, we kind of view the mRNA in sets of 3 nucleotides. So these sets of 3 nucleotides are going to each match up with a particular anticodon. So what do you think we probably call the set of 3 nucleotides of mRNA that matches up with the anticodon on the tRNA? Good, they're codons. Okay, so like for this first one here, it says CCA for the mRNA codon. So it matches up with a tRNA that has an anticodon of GGU. Does that make sense so far?
So
codons are segments of 3 mRNA, and they match up with an anticodon that's on a particular tRNA.
So
yes.
tRNA has how many amino acids?
tRNAs carry amino acids. Yep. Yes. So codons are sequences of 3 amino acids, and then anticodons are going to be a matching set of 3 amino acid, of 3 nucleotides that are on a tRNA. So like, for example, let's do a little example one. So, and you remember how there's like 20 main amino acids? Well, each of those 20 main amino acids has a particular anticodon that's always at the other end of that particular tRNA. So like, let's make it really easy and say A is the anticodon, and then this is the amino acid that matches up with that anticodon. So what's the codon going to be that this tRNA matches up with?
G.
What does A match up with?
U.
Good.
Oh my God.
It's okay. It's okay. All right. So U. All right. So that's kind of how it works. And we're going to do a project that's going to help us to better understand that. So the overall stuff that I want you to get from this picture is the fact that this is kind of what the ribosomal structure is. Obviously RNA. It doesn't look like a perfect shape like this. It's not like actually, it's more like globular than this is. But so the ribosome is composed of rRNA. The messenger RNA is coming over from the nucleus. The tRNA is going to have an amino acid on one side and an anticodon on the other side. And we're going to match those anticodons up with the codons of mRNA. Okay? Another important thing to know is that the codon at the beginning of the mRNA sequence is called the start codon. And then the codon at the very end is called the stop codon. So this one's going to signal the start of translation, and then the one at the end, it basically gives the signal for no amino acid to come over, and so it stops translation. Okay? What type of bond are we going to have to form in between the amino acids as we go? In between the amino acids. You said it. Go ahead. Peptide. Peptide bonds, good. When the anticodons match up with the codons, that's a hydrogen bond that's being formed there, and they'll break later. I'm sorry? Amino acids are bonded together with peptide bonds.
What was the thing you said earlier class that was like, I got it.
These
Yeah.
are amino acids with peptide bonds in between.
Well, What was the thing you said during class? The other type of bonds, like during biodial?
Phosphodiester?
Phosphorylation bonds or
Phosphodiester.
phosphodiesters?
That's the bonds between the phosphates and the sugars of nucleotides. Okay. All right. We're going to go through the process, and I think that some of our like more fuzzy areas will be cleared up a little bit. Okay. So here's the first part of translation. So we've got the ribosome. We're in the cytoplasm right now. Here's a ribosome. We've got tRNAs that have amino acids on one end and an anticodon on the other end. We have mRNA that's traveling over from the nucleus. Which end of the mRNA enters between the small and large subunit of the ribosome? The 5' end. So the 5' end is going to enter, and it's going to move right up under the A site. Okay? When it moves up under the A site, you can think of it like the activation site. So once it gets into that A site, a tRNA is going to come in that has the matching anticodon. Okay? So this first codon is AUG. So the tRNA comes over that has what anticodon? The first codon is AUG. So what's its matching anticodon? UAC. So a tRNA comes over that has UAC and has an amino acid at the other end.
Wait, is it always those letters?
That's the only start codon, so it's always going to be AUG that starts it off. Okay? So that first one is now in the A site. Okay? Once that particular tRNA comes and forms hydrogen bonds between the codon and the anticodon, then the mRNA is going to move in one more codon. Okay? So look down here at number 3. You can see that the next codon has moved in as well. So we've got the next codon is CCG. So we had AUG and then we have CCG. So what's going to be the anticodon that matches up with it? GGC. And it's got a different amino acid at the other end. Each anticodon codes for a different amino acid that's going to be at the other end of the tRNA. So once we have 2 amino acids next to each other, then there's going to be a peptide bond that's formed between them. We've just started a polypeptide chain, which is a protein. A bunch of polypeptide chains together is a protein. All right? So,
How do you get a polypeptide chain?
so this is an amino acid. This is an amino acid. We put a peptide bond in between it. Now we have the beginning of a protein, right? Uh-huh.
How do they build on top of each other?
Why do they build on top of each other? Because we're trying to make a protein, and we have to bond the amino acids together to make a protein, because a protein is a long chain of amino acids.
So on the WebQuest thing,
Yeah.
we did like the last thing we were supposed to do was like you connected these together.
Uh-huh.
And it was like men, TYL, like.
Yeah, those were the different amino acid names. And we're going to get into that. We're going to do that later on today. Okay. So next, now that we've bonded 2 of them together, what's going to happen is that this original tRNA is going to move over to the E site. We're going to move in one more codon, and once the tRNA moves from the P site to the E site, the tRNA releases its amino acid. Okay? Because it's already connected to the other one, and they just don't need to stay, the tRNAs don't need to hold on to the amino acid anymore. So you can see in picture number 4 that the tRNAs, once they move from the P site to the E site, they actually release their amino acid to stay part of the chain. Okay, so you can see that very first one. Y'all look at the screen for me. So this very first codon has moved all the way through the ribosome at this point. And this very first tRNA started here, went here, and is now leaving to go get another amino acid and come back later.
So it's just, okay, the P side has 3.
Yes, because it has the ones that these 2 guys have.
So always,
Can you look at the board for me? It has the ones that this one and this one had.
so it always builds from the P site? You get like
Yes. The P site, the tRNA that's at the P site holds on to all of the amino acids from the previous tRNAs.
Not immediately when the first thing, first tRNA goes to the P site.
When a tRNA moves from the P site to the E site, it releases its amino acid. Okay? All right, so, and then the last thing is that we get to the stop codon and it signals no amino acid, and so we're finished. Okay, so let me start at the beginning one more time, go through it real fast. So we've got the ribosome, the mRNA is coming over from the nucleus, we've got tRNAs. We're going to start off with initiation, which is where the mRNA enters the ribosome at its 5' end, and its start codon is going to be that first codon that enters. And so the tRNA is going to come over that matches up with the start codon and bring its amino acid. All right, so codons and anticodons match and form hydrogen bonds between the A site and the P site. A peptide bond is formed between the amino acids and a polypeptide chain begins to form. This is called elongation and translocation. The elongation part is the fact that the amino acid chain is getting longer as the tRNAs move through. Okay, the translocation part is the actual movement of the tRNAs. Give me 1 second, Nikhil. I'm going to get through this and stop the video, okay? And then tRNAs that have released their amino acid are let go through the E site and go to find another amino acid to bring back, okay? And then when the stop codon gets to the A site, it terminates translation, and that's called termination.